Good morning to all. So this is Ulumar from SNS College of Technology and the Department of Computer Science Engineering. So now I am going to tell about memory management. So in the memory management, we have discussed about we will going to discuss about segmentation concept. First thing, so what is segmentation? In a segmentation, so each and every memory management schemes that supports user view of memory. So in a segmentation program is a collection of it is a collection of segments. So in a segment is a logical unit such as main program and a procedure and a function and method and object. So local variables and global variables and common blocks and a stack and system table and arrays. So see, these are the logical units in segmentation. So in a C compiler, so it might create a separate segment for this following concept. So in a C compiler, it created the code and the global variables and the heap and from which memory is going to allocate to heap, and also they are using a stack, so used by each thread. So and also it is used for standard C libraries. So this is the user view of a program. So we have a logical address. In a logical address, we consider that we have a subroutine and a stack and a simple tables and a main program and a square root functions. So in the main program, we have to create a number of main program functions. So that is mean that, so we have to write a C code with data types, and we have to write a subroutines in the simple programs. So what is a stack means? It is you are going to use in one by one functions. It shows that we are using the stack function. So this is the logical view of segmentation. So we have two different phases. One is a user phase and another one is a physical memory phase. So in a user phase, we consider 1, 2, 3, 4 as a subroutine concept. In a physical memory phase, they are assigned 1, 4, 2, 3 is in an ascending order, because because the segmentation means we have to execute which program is going to execute a low time. So that is the executor first thing. So in a segmentation architecture, so in a segmentation, the logical address and consists of two tuple. So that is called as segment number and offset. So segment number means we have to assign some number to the different segmentations, and offsetting it means it is a one type of resource weighting functions. So in a segment table, it maps two-dimensional physical addresses. So each table entry has base and limit. So each physical address consider the base address as well as the limit address. So in the base address, it contains the straight physical address, so where the segments resides in a memory. So in a limit address, it is specify the length of the segments. So we have two different registers. One is a segment table base register, second one is a segment table length register. So in a segment table base register, it points to the segment table and it is location in a memory. And then segment table length register, it is indicates the number of segments used by a program. So segment number S is legal, S is legal. Then if S less than or segment table base register table length registers. So it have some kind of production. So in a production means we have to with each entry in a segment table associated. So it is an validation bit equal to 0, then it is an illegal segment. Then the segmentation will consume read and write and execute privileges in following orders. And the production bit associated with the segments. So the code sharing occurs at a segment level. So the segment in a segmentation is a very vary in a length, and also memory allocation is a dynamic storage allocation problem. So in a segmentation, each and example is shown in the following diagram. So you can see the segmentation hardware first thing. So first one, we have a CPU and a physical memory. So in between the CPU and physical memory, so we have a trap and a segment table and an option condition. So when we send any execution of a program in a CPU, the first thing is when we can send to the source, then send to the segment table. So in a segment table, it considers a limit and base address. So both addresses are add and then send to the physical address. So before that, the offset is created in a limit based address, so it will directly send to the trap, I mean addressing error. So when we have a getting a addressing error, so it will consider the base address limit address. Is this greater than means the base address added and then sent to the physical memory. It then less than means is directly sent to the offset. So offset is one type of error in a segmentation. So we in this diagram we have discussed about segmentation example. So we have one side is logical address space, another side a physical memory. So in a logical address space we contains a subroutine, a square root, and a main program, and a simple table and stack, and it is named as a segment 0 1 2 3 4 5. So in between the segment table, so segment table contains limit and base address and a physical memory. So which we have to share the logical address to physical memory. So segment 0 is assigned to 1400 to 2400 because the limit is 1000 and the base address is 4400. So that we have to ensure that the segment 0 is placed in 1400 place. So following that, they other than the same as in the segment 0 and then 2 3. So depends upon base and limit address, the segment is placed in the physical memory. So this is the reference for my segmentation concept. Thank you.